Hello everybody, equivalent form versatile practice in a spider. Okay, get that out of the way. Okay, we started this in class today and you're supposed to take it home and finish it tonight for a review for tomorrow's test. So if you're having a hard time, maybe this video can help remind you of some strategies we've done. So looking at number 1, it says the model represents one whole. This would be one whole. What decimal and percent represent the shaded part? So if the whole thing is out of 100, how many are shaded? 10, 28. 28 out of 100, which would be 28%. Or the decimal would be 0.28, which is 2 in the tenths, 8 in the hundredths, 28 hundredths. And that does not match A or B. C, it matches this half, but not the percent. D is good on both occasions. So D is the answer for number 1. So up at the top where it says D, we put 1. Okay, let me switch colors here. We're going to go to number 2. Dennis spent 17 of the $20 in his wallet. Which decimal represents the fraction of the $20 Dennis spent? Well, this is a fraction question. You do not subtract 20 minus 17. That's not what it's asking for. What fraction of the money did he spend? He spent 17 out of $20. Now, all of our decimals go to the tenths, hundredths place, hundredths place, hundredths place, hundredths place. So based off of that, we want to make our denominator go to 100. Well, how does 20 get to 100? Times 5. What we do to the bottom, we do to the top. So I'm going to find out what is 17 times 5, and I'll know my numerator. 35, carry the 3, 5, 6, 7, 8. So it's 85. That gives me 85 hundredths, which goes with answer choice B. So for number 2, I'm going to put a 2 in the B spot. So here's the 2 in the B. Or not to be. That's not funny, Miss Hester. Okay, number 3. A black snake can grow to eat a spider. Okay, can grow 1.94 meters long. Which fraction is not equivalent to the length at the black snake of the black snake in meters? So what I'm looking at here is one whole. Check. Check. 94 is in the hundredths place. 94 hundredths. And then this is 24 over 25. So what I need to do is see if 25 times it by 4, that gives me 100. If 24 times 4 also equals this 94. So I'm going to come over on the side and do 24 times 4. See if they're equivalent. 16, carry the 1, that's 8 plus 1. That gives me 96 hundredths. Now, if this is correct, this should match it, but it doesn't. It gives me 96, so it might be E. Okay, let me check J, just to be sure. Okay, 1 in 94 hundredths, 1 in 94 hundredths. We know that this is correct. If I do the Texas 2-step to make this mixed number improper, let's see what we get. First, I'm going to multiply 100 times 1. That equals 100. Then I'm going to add the top number, 94. That gives me 194 hundredths, so that's a match. Now, this is improper over here on B, but if I take 50 times it by 2, will that give me 100? Yes. Does 97 times 2 equal 100? Have some space over here. Let me try it. 97 times 2. 14, carry the 1. 18 plus 1 is 19, 194. All right. So B can enlarge up to 194 over 100. A matches 194 over 100. The one that doesn't match is E, and we're looking for the not equivalent, so 3 goes with E. So in the E, let's put a 3. Okay, number 4. Move it down a little. As part of a workout regime, Kendall's coach has required she meet several fitness goals each week. I need to do some of that myself. So far this week, Kendall has completed 65% of the total number of push-ups required by her coach. Here's the question. Finally, the question. What decimal is equivalent to the percentage of 65? So we know that to get from a percent to a decimal, we locate where the decimal is. If we don't see it, it's in the back. And then percent to decimal, PD, that's like police department telling you go back 2 spaces. So we're going to go back. And that gives us a 0.65. So my answer for 4 is going to be C, 0.65. So up at the top, find the C, and you put a 4. 2, 4, 1, 3. Okay. Number 5. A school basketball team spent 44% of its fundraiser earnings to purchase new uniforms. What fraction of the fundraiser earnings was spent on new uniforms? So we are trying to make a fraction. Well, 44% is always going to be 44 out of 100. All percents are out of 100 or over 100. Now what I can do is reduce this down to see what fraction it matches. So let's think. How can I get 44? What times what is 44? I'm thinking 4 times 11. Well, 44 can be divided by 4 or 11, and 100 can be divided by 4, but not 11. So I'm going to divide both sides by 4, and on the top I get 11, and on the bottom the denominator is 25. Does that match? No, no, yes, no. So the answer for 5 was L. Let's go back up to the top. Where is L? There's L at the end. Put a 5. And going back down again. Okay, number 6. Halfway there. Drake is assembling a box of sweet treats for his mom to take to elderly individuals on their Meals on Wheels route. The table below shows the contents of the box. You've got sugar cookies, brownies, Rice Krispie treats, oatmeal bars. Ooh, I like Rice Krispie treats. What percent of the treats are brownies? So we got to make a percent out of the brownies. I see that there are 10 brownies out of how many total? 20, 30, 46, 50. 10 out of 50, which we can reduce to 1/5, or we could build up to 20 out of 100, because all percents are out of 100. Now to get to 100, we could do 50 times 2, and then you'd have to do 10 times 2. Or you could know that reduced 1/5 is a 0.2, and when you move the decimal 2 places, 0.20. However way you work it, the answer is A, 20%. So go to the top and find A, and we're going to put in a number 6. 6, 2, 4, 1, 3, 5. Okay, flip. Okay, I had a lot of questions on this one, and they were some good questions. What's happening here is this shaded rectangle represents 100%. So if the whole thing is shaded, that's 100% shaded. What we're looking for is for 33 1/3%. Now, which one of our benchmark fractions had 33 1/3%? That would be the 1/3, which matches very nicely with J, 1 out of 3. On D, what's happening is this is 3 out of 3, which is 1 whole, which is 100%. So this would be another 100 and another 100. This would be 300%, just these 3 alone, and this one would give us even more than 300%. I don't want 300%. I want 33-ish, 33 1/3%, around 33%. F is 6 out of 6, which is 1 whole, which is 100%. And then on I, that's a third and a third and a third and a third. Basically here I have 4 thirds. that means I have 1 whole and 1/3 left over. For example, if I were to take this block and shade it in here, and then take out this block and shade it in here, this is 100%. And this is the 1/3, which is 0.3333 forever hat. And if you recall, 0.333 forever hat, when I make it into a percent, whoop, whoop, that gives me 33.3 forever hat vinculum percent. So do I want 133.3 forever hat percent? No. I want J, which is 33 1/3%. Or we could also call it 33.3 forever hat percent. They both work. All right, so 7 is J. Go to this side, find the J, and we're going to put a 7. Why are some of these purple and some of these green? I have no idea. I just kind of went that way. Number 8. Which of the following equations is not true? So we're looking for the not true. Let's look at F. This is improper. I'm sorry, this is mixed, and it's going to improper. So to get from a mixed to an improper, we do the Texas two-step. 3 times 6 is 18 plus 2 is 20. Check. Over 3, check. So F, these are equivalent. We want the one that's not equivalent. Okay, H. 3%, 3/100ths. All percents are out of 100, so these match. That is true. Let's check G. 2/5. The fifths are on your hand. Each finger is worth 20. So draw a little hand. Ooh. Good thing I teach math, not art. And if each finger is 0.2, 0.4, 0.6, 0.8, 1 whole. Each finger is worth 0.20, 0.40, 0.60, 0.80, 1 whole. 2/5 would be 0.40, not 2.5. That never happens. So that's the bad one. Let me check this last one. If I have 5 quarters, think of money. If I had 4 quarters, I'd have $1. If I have 5 quarters, I have $1.25. That is true. So G is the correct answer. So for G, let's put the number 8. And G is 8. Ta-da! Oh, sorry. G is 8. All right, flip. Jamir? This guy entered a free throw contest and made 0.68 of his free throws. What percentage is equivalent to that decimal? Easy. To get from percent to, that's a decimal. To get from decimal to percent, it's like a Dr. Pepper. And you find where your decimal is, and to get a Dr. Pepper is a good thing, and it makes me feel all right. Move 2 places to the right. Whoop, whoop. And that gives me 68%, not 0.68, not 6.8, it's F, 68%. What is that? Oh, those must be the ones that he didn't make. Good job shooting those free throws. Okay, so F gets a 9. So flip it over. F gets a 9. Okay, back to the front. The back. Whatever. Okay, so this dot on number line is shown below. Which of the following numbers best represents point X on the number line? So this dot here looks like it's less than 1.5, but more than 1 whole. Now let me go to the easy one. 105%. The decimal's at the back. To make a percent to a decimal, I go back 2 places. Police department says go back 1, 2. So that gives me 1.05. That's like $1 and a nickel. This is like $1.50. So $1 and a nickel will be way over here. It's not H. Okay, let's look at E. 7 quarters. If you want, you can do top dog in the house here. 4 goes into 7 one time. 1 times 4 is 4. Subtract, I have 3 left over. Put the 3 over 4. That's 1 3/4. Or it's one of our benchmarks, 1.75. 1.75 would be over here, between $1.50 and $2. All right, so maybe it's I. Let's do top dog in the house again. Bottom outside. 5 goes into 7 one time. 1 times 5 is 5. Subtract, I get 2. 2 over 5, 1 whole, and 2 fifths. Okay, or you could do it as a decimal, which would equal, I'm looking at my hand, the fifth, 20, 40. 2 fifths would be 1.4 or 1.40, which would fit very nicely with X. I is the answer for number 10. So go back to the front, and for number I, put letter 10. I know I said that backwards, but it was fun. Okay, 2 more to go. Woohoo! Okay, 11. Let's see, which of the following represents a set of 3 equivalent numbers? Okay, we want the ones that match. 13 over 5, let's see what we get. 5 goes into 13 2 times, that gives us 10. There'd be 3 fifths left over. 3 fifths, let's look at my hand, 20, 40, 60 is a 0.60. So 2 wholes, 0.6, that works good. K is great. Wait, is this our answer? I hope so. Let's check the others to be sure. Okay, 14 fourths. How many times can 4 go into 14? That'd be 3. 3 times 4 is 12. That would leave 2 fourths left over. So J is not right. So it can't be all of them because J is wrong. Last one. How many times can 4 go into 17? They said 4 times. 4 times 4 is 16. I would have 1/4 left over. So L is not right. K is the answer. So K gets an 11. Now, based off of everything we've done, H should be the last answer. Let's find out. Oh, this one's tricky. Let me switch to green. Mrs. Simmons has 9 granddaughters and 15 grandsons. What percentage is equivalent to the fraction, oops, I didn't mean to do that, fraction of Mrs. Simmons' grandchildren who are boys? Okay, how many were boys? 15. Out of how many total grandkids? 15 plus 9 is 24. And then I would ask my students having problems with this, how can I get to 15? I can do 5 times 3. Now, can 5 or 3 go into 24? 3 can, so not the 5. So I'm going to take 15 divided by 3, I get 5. 24 divided by 3 is 8. And that's 5/8. That's one of our benchmarks. 1/8, 0.125. 2/8, 0.250, and so on. But if I know 1/8, if I can memorize that, I could times it by 5 to get 5/8. 25, carry the 2, 10, 11, 12, carry the 1. That's a 0.625. Or maybe you memorized it. Now, to get from the decimal to the percent, we do a all right, woohoo! 62.5% matches H. You were correct. H. So here's your final answer, 6241398. H. Really? Did I really just do that? Oh, Lord help me. 12, 10, 7, 11, and 5. And when you put them into the versatiles, it'll make a nice little pattern, which turns out to look like this. Get higher for the children to see. There you go. Okay, I hope this was helpful. It was 19 minutes long. Have a good evening, and good luck on tomorrow's test. Bye.
Bye.